In this video I'm just going to do the B part of this question. A part I did in my previous video, you can watch that, but in this video we are just going to focus on the B part. In the B part, the question is asking, neglecting the effect of output resistance RO, find AD in terms of mu and mu P, W over L 1 2 and W over L 3 4. Okay, AD is the gain. Okay, we calculated the differential gain, that's the AD. We did it in the part A of the question, and I'm gonna just write the expression we derived in the part A. In the part A, we derived AD to be GM12 and then RO1 parallel to 1 over GM3 parallel to RO3. Okay, and here one thing that is true is that GM3 is a very large number. It means this 1 over GM3 is going to be very small, and when we have parallel resistance, it's going to take the smallest value. So it means in these parallel resistances, RO1 parallel to 1 over GM3 parallel to RO3, the equivalent resistance is going to be 1 over GM3 since that's the smallest one. Okay, so now this equation, AD equation, becomes GM12 over, okay, let me write it better, GM12 over GM3. And if you look at the MOSFET in the diagram, 1 and 2 are NMOS, and they said these two are matched or some. Let me double check. Drain resistor, PMOS transistor. So Q3 and Q4 are matched, Q1 and Q2 be matched. So it means the transconductance for the Q1 and Q2 are the same. The transconductance of the Q3 and Q4 are the same. So here GM12, that's the transconductance of the 1 and 2, and GM3 must be equal to GM4 as well. So we can also write this one as GM12 over GM34 as well. Okay, now the question asking us to express this one in terms of mu and mu P, W over L, W over L12, W over L34. In order to express in that way, we have to know the transconductance equation. Transconductance is given by this formula: GM is equal to square root of 2 mu COX W over L times the ID current. Okay, this is the expression of the transconductance equation. Now we have to express this one using this. If we do that, let's see what happens. I'm going to go to new page and I'm going to copy the equation again. AD is equal to GM12 over GM34. GM34, and here when we are considering this equation, there are only few things that's going to change according to the MOSFETs. So first one, the mu COX, it depends on whether it's a NMOS or PMOS. For the PMOS, we will have this one as mu PCOX. For the NMOS, we will have this one as mu NCOX. And the width over length ratio is going to be same for 3 and 4, and it's going to be same for 1 and 2. So it's going to be based, that is going to be based on that. And other than that, this COX to ID is going to be equal for both of them. Okay, so based on that information, we can cancel some of the term. Like, let's see how it's going to be. So if we express this one first, let's write this one fully. So this is first I'm writing in terms of 1 and 2. If you look at 1 and 2, those two are NMOS, because you see the arrow pointing outward. So these two are NMOS, so this is going to be 2 mu and COX W over L 1 to ID. Square root of 2 mu and COX W over L 1 to ID. And they also mentioned that equal current flow as well, since it's matched. So the current is going to be same, because whatever the current come here should be the exact current come here as well, because there's no current through the gate or anything. Whatever the come is in the drain is exactly going to be right here. Okay, so ID current is equal, and if you look at the bottom, we have PMOS here, exact same formula, that is 2, and instead of mu n we put mu p here, and then COX here we are going to have W over L 3 4 and then ID, and here we can cancel some of the term. We can cancel this 2 2, we can cancel this COX, we can cancel this ID. Once we cancel, we will end up having mu n over mu, let's put the top term first, mu n times W over L 1 2 over mu p times W over L 3 4. Okay, and this is the AD expression, the differential gain expression in terms of mu n, mu p, W over L 1 2, W over L 3 4. And that is it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.